guys, welcome to Home IO Google Hangout. Home IO Google Hangout on home automation. Now, home automation is a very interesting topic which many of the people are dreaming about to automate their home. So this Home IO is a platform in which you can automate a virtual home using your own logics, and you'll have so much of you can say exposure about sensors and actuators and how to link those we are going to see in Home IO. Home IO is a software platform in which students, kids, even engineers and geeks can apply their logics and can automate their home. We have more than 174 sensors and actuators in this simulation. It's a 3D simulation, really thrilling to work upon, and we'll be using Connect IO. This is a platform in which we'll be making a logics. So I'm Rajveer Singh. I'm the training director of NFI Automation Training Academy. I provide online training to many different countries across the globe. So here I am to introduce you a Home IO, a platform to automate the home. Okay, so let's see what we can do that. So if you have the software, if you are already buying the software, you have it in your system, you just go to New and click Confirm. Now, that's the smart home environment. So what we're going to do here is we have the smart home here. So let me take you to the entrance. All right. The entrance is over here. This is the main gate. All right. That's the main gate. So what we're going to do here is let me open the door. So let me be completely out of here. All right. So that's the gate and that's the sensor. All right, these are the infrared sensors. Now let's see that many times we have automatic gate here. So let's say this is an example of automatic gate. We want to control the open and close operation of this gate by the sensor. All right, so naturally, physically, if somebody comes near the door, if any vehicle comes near the door, these sensors will be on and this gate should be open. And when the vehicle crosses by, this gate should get closed automatically without affecting any other systems. All right, so this is our first task. So to do that, we have to do several steps here. So the first step is here. This is a control console. All right, right now you can see that this is a red icon here. Let me show you. Let me crouch. There's a red icon. It means it's deactivated. It's manually operated. All right. So to activate that in my Connect IO, to access this control in my Connect IO, I have to turn that to blue. All right. When it is blue, I have its sensors and actuators in the tags column. So these are the different sensors and actuators. So let me just squeeze the window so that you can see all together. All right. Let me squeeze that. Now this is what we call Home IO meets Connect IO. Connect IO is a platform which is used to connect the technologies. So not only Home IO, we can connect many other technologies with this Connect IO software to control the logics. All right. Okay. Now this is the control console which has been connected to Connect IO by this blue symbol here. Now the task is to open the gate by the sensor, this one, the first sensor. Now this sensor is infrared sensor 1 in the Connect IO. If you notice this bit, if I go near the sensor, this bit is on. All right. If I go back, this is off. So if I'm in the range of the sensor, this will be on, and otherwise this will be off. And to show you the open and close operation, this is the output bit. Entrance gate close, and the color is little maroon. And this is entrance gate open. So if I turn on this bit open, this gate will start opening. If I turn it off, if I turn on this bit, this gate will start getting closed. So let me show you manual operation first before coming to the sensors. So in the source, you will get a bit. This is a manual bit which I can take in Connect IO. So if I just click here and click here, this will be connected by a wire. All right, now if I press this bit in Connect IO, you'll find, hold on, door will start open. All right, this is how door starts opening because I turned on this bit. Now one more interesting thing is we have two more feedbacks: gate opened, this one, and gate closed. All right, now this is the feedback which will tell us when the gate is 100% open or when it is 100% closed. Okay, so if I open the gate, now this is 100% open, that's why this bit is on. So this is the feedback. Okay, we have some sensors or limit switches connected in the Home IO which will give us the feedback. Now I'm going to connect this switch from here to close. All right, now when I press close, you'll find the gates start moving and it's getting closed. And when it is 100% closed, you have this feedback on here. like this. Okay, now if the feedback is here, I should not close it further because it may damage my motor. All right, so this is the different bits we have in the connect out. Now let's automate that. So we have two sensors here which we are most probably using. This is the sensor 1, infrared sensor 1, and the second one is this one. This is the infrared sensor 2. So just to show you, this is the sensor 2. So if I come in the range of the sensor, this is on, else this is off. So this is transmitter and the other one is receiver. Okay, this is a receiver. Here it is. That's the receiver. So how should we automate that? Now, this is the logic. Now, this is my sensor 1. So if you are new to logics, if you are new to creating logics, what is the first that you'll do? You'll just click the sensor 1 and you'll go to open. All right, and you will go to infrared sensor 2 and you will make it close like that. This is every immature programmer will do. So, but this is not reliable. Why? Because if I'm standing in front of the gate, this is open. Suppose if I step back, this will pause there, which we don't want. We want, if we are in front of the sensor, even for a pulse, single second, this should completely open. This should completely open. All right. So we just want a latch operation. In this case, we don't want this momentary operation. This is called momentary operations. We want to latch the gate, latch until this is 100% open. All right. So to do that, we have some functions in ConnectIO. We have some plugins in ConnectIO which are very much used. So let's see the plugins. Now, if you are aware of some programming, we have set, reset, and reset set flip-flops in digital electronics. All right. So these flip-flops will be used to latch the outputs. So let's take an example of RS. RS is reset set. Okay, it's a kind of flip-flop. So what we're going to do is, now in reset set, what happens when you give a pulse to set, the output of this flip-flop will remain latched. It will remain on, irrespective of any other pulse in the here. If the pulse on the set is removed, even then this will remain on. That is RS flip-flop. And if you're giving pulse at reset, this will be off. Output will be off. So what we're going to do is, this infrared sensor will go to set, and when the gate is 100% opened, that is a feedback that should be connected to reset, and the out should go to open like that. Okay. Now what will happen if the sensor is on? This will set this block, which will set the output. By set, I mean it will turn it on until it is being reset. It will remain on until this pulse comes from the gate open bit to reset the output. Even if you are turning away from the sensor, this will remain on. All right. So similarly, we'll do the same function. We can do the copy paste operation for the gate close as well, like this. This will be reset. Sensor 2. This will be set. Okay. Now let's see an example. I'll just go in front of the gate like once. Now even if I turn back, this will remain on until this gate is 100% opened. So this is how we just automated the front opening operation of the gate. Now the second sensor. When the second sensor is on, this will set a pulse to RS block, which will set this bit of gate close, and then you have your gate closed until it is 100% closed. This gate close command will be on like that. I'll just move like this. Now gate close bit is on, so gate is starting closed, and this bit will be off when this is 100% closed, like that. Okay, now it is reset. Now this RS means this is reset dominant. All right, reset dominant means if both the inputs are on, this is on, this will reset the output. That is what we call reset dominant. So this was a basic example of how to latch and unlatch the main gate door. We can do much more in that. We can use some rising edge and falling edge to change the application. We can use counters and we can use timers also to change the application. So we'll be discussing that a bit later, because this hangout is all about introducing you to HomeIO various features. Okay, this was the first feature, entering the gate. We have a lot more things inside it. Okay, so let's talk about the second thing here. Now we have a siren. It's a siren for alert, siren alert. And you have a brightness sensor. Now brightness sensor senses the luminance outside, the day luminance, and based on that, it gets on and off. Okay, so let's see how we can work with that. So let me remove all the bits right now. I don't need these anymore. Let's take this. Okay, let me just take out the control as well. All right. Now we are going to work on the sensor. I'm turning that to blue. By turning it to blue, I have its control here. Now I have two bits. One is analog, one is digital. The best thing is in home IO, we can work on analog signals and digital as well. So analog is it is proportional signal, proportional to the luminance. Digital is just on and off. All right. Now this is a brightness sensor. Using that, we have to turn on the lights. So I'm turning on. I'm taking its control on the connect tile. It's blue. We have the lights here. So let's work on as of now digital. I'm having a light here. Now we have more lights in another area. Let's see what we have there. The advantage is you can hang around anywhere in the connect tile in the home aisle. So this is the back side in which we have porch light and the pool light. All right. So let me see the control of this porch light. Here is the control. I'm going to have these lights in connect tile because what I want at the night time, this light should be automatically on, and during the daytime, these should be off. So, and this is my pool. Let me maximize it. That's my pool, and I can activate the controls in the connect tile here as well. And yeah, this as well. All right. So I've took the control of the lights. Now I have to automate this. Okay. So I have light gardens already here, light pool here, light Porsche 1 and Porsche 2. All right, so we have 4 outputs. This is a function of connecting outputs in parallel. Now the amazing thing is, what do we want here is at night light should be on, but if you see the current time is 15:43.02. So I don't want you to wait for another 10 hours to see the darkness. What I can do is I can skip the time. I can fast forward the time like that. So let's go to 10 in the evening. So by doing the slider, I can fast forward the time, and you can see the effects in the home IO. All right, now we are at night, and you can see that this bit is on. All right, at night the sensor is automatically on because it is sensing the luminance, and in the daytime this will be off. So it's very simple. Now what you have to do is just connect this bit. Light pool, so pool light is on. Porsche, this is on again. Porsche 2, this is on again. And this one, light garden, is at the backside of this home, which is also on. If you go there and you can see, you can find it. So this was very simple because the sensor is on, so you just connect 4 bits all together and you are turning on the light during the night. And what happened during the daytime? So let's see. Let's move to 10:53 in the morning. Now when I skip the time again, during the daytime the sensor bit will be off, so as your home IO lights will be off. So these are off because these bits are off. So it's pretty easy. So we have automated the porch light, pool light, and the garden light. All right. So let's move inside. Let's see what we have next. So I'm going to the entrance now. Earlier I was just roaming around. This is the entrance. Okay. Now in the entrance you will find a light and a motion detector. Okay. So let's remove that. We don't need this. We don't need this anymore. And also we should deactivate the sensors. So very quickly I'll just go there and deactivate it because it may confuse me when I'm going to tag the things. By red I can deactivate these from my connect IO. All right. And you know, this connect IO software is an open source software. You can download that from our website, from Real Game website, for free. And you can practice these bits. And also we have a free course on connect IO, how to make series parallel circuits, how to use counters, set reset bits. You can learn it for free. It's just a 45 minutes course, and you can learn that how to make logics. All right, so we are here. In the entrance we have, this is a motion sensor. Motion sensor detects the motion, only the motion, not the presence or the absence. If you move, then it will be on. All right, so let's take its control in the connect IO. So we have motion detector here and this light here. So what do we want? This is a light entrance. We want, if the motion sensor is on, this light should be on. If the motion sensor is off, light should be off. It's very simple. Take motion detector bit here, light entrance. Sorry, this is garden. Light entrance over here. And if you just connect it like this, now if I move, the light bit is on. And it's an internal function of this motion detector that when it sends something, it is on for 5 seconds of its own. All right. Now, if you want to change that time from 5 to 10 seconds, or even 15 or 20 or 30 seconds, you can do that in ConnectIO. By default, you're going to do that. It will be on for 5 seconds and this will be off. If you want to customize that, let's see how we can do that. So what we're going to do is we are going to use again set reset block. Let me see where is that. You can use, okay, let's use SR this time. Now this motion detector is going to set the block. Output will go to light entrance. All right. Now with this light entrance, we are going to run the timer. Okay, with light entrance, because we need to turn off the light after, let's say, 15 seconds. So we can have a timer in the ConnectIO. That timer will come over here, T on. Okay, so this light is going to turn on the timer. In timer, we have 4 functions here. This is the input. This is the input which activates the timer. So what do we want after the light is on? It should activate the timer. PT is the time for how much time you want to put delay. So to give the delay, we can go to source and we can find a numerical. In this numerical, we can enter some values. So in this timer, you must know that we are giving time in which units is milliseconds. All right. So if I give it 10,000, it means it's 10 seconds, 10,000 milliseconds. So I have a timer of 10 seconds. So after 10 seconds, this Q will be on. Okay. Q is the output. With this Q, I want to reset the light. So what I'm going to do is with Q, I can take an output bit. Okay, this is my output bit, and I can copy that, paste it here, connect this output here. So this bit will be on after 10 seconds of this timer. After 10 seconds, this will be reset and the light will be reset. At ET, I can see my time, the current time. So to see that, I'll take an int, give it the address 1, and connect it like this. Now in this logic, you will find what's happening here is when the motion detector is on, this block is set, which is going to turn on the light, latch the light, which will turn on the timer, and after 10 seconds, this bit will be on, which is over here as well, which will reset the block, which will reset the light and reset the timer as well. So have a look. I'll just move in the ConnectIO. This is on, time is started, and you see here, this is on for 10 seconds. 9, and at 10, light is off. Okay, I'll do again. I'm moving for another 10 seconds, light will remain on. All right. So that's how you can customize your home IO operations by using ConnectIO logics. All right. So let's move inside. We have much more to do. So now I'm inside the home IO. So we have a lot of controls here. Okay, let's see these controls. Okay, let me just turn off this logic. Alright, now here we have a couple of controls. This is the motion detector, which we have outside as well. This is the siren. This is the gate detector bit, which detects the opening and closing of gates. This is the brightness sensor and some password control here. Alright, so let's do an operation. Like if somebody lock the home by entering the password, somebody secure the home. After that, if somebody opens the door, maybe this one or the other one, this one, or if somebody moves inside the home, if this motion detector is on, this will turn on the alarm after putting the password, after securing the password. Okay, this is, let's see, this is an application. So let's talk about the door first. If somebody opens the door after entering the password, there should be an alarm. Okay, so we are using 3 things: this one, and this one. Okay, you'll wonder that we can make logic so quickly here. Okay, so let's move to ConnectIO. Let's see the tags we have in here. So in tags, you have one is alarm key, arm. This is the output bit. If this is on, this alarm will be on. Armed is a feedback that alarm has been secured. This is a disarm. This is an output bit. I will tell you what is that. I'll explain you. Then one, we have a siren here. Then we need motion detector we already have. Then we have this one. This is by name. Oops. Door detector 2. So this detector is already on because door is closed. All right. Now you have this alarm key. Now let's see how this works. If I put the password, the default password is 1234. If I put 1234 and click on this lock, you'll find this has been armed. Okay. This is a feedback that it has been armed. If I put 1234 and click this one, this is disarmed. All right. Now these are the output bits. If you want to alarm this security lock using some external control, you can also do that. For example, if I go to source and take a small bit and I do like that, this is armed. Okay. This is a kind of beep we get, and this is already armed, and this is how it is disarmed because this is already pressed. So what we're going to do is we have to make a logic. Once it is armed, this is a feedback. Once this armed bit is on, then if door is open, this door is open, we need to have a siren on. Okay, so when this door is open, you have this as NC. I mean, this is off. Okay, so let's take a NOT gate first. We can do that by a step-by-step operation. NOT gate, you will get here a NOT gate. Okay, connecting here like this. Now I need an output when this gate is open. So I'll get output from NOT gate when the gate is open and when the alarm bit is on. All right, so let me put it aside a little. This is my siren. When this armed is on and when the gate is open, I need an alarm. So if you think which type of gate we are having here, when two things are on, then output is on. Only when these two are on, we need to have an AND gate. So we'll take an AND gate here. This is my siren, and this will go to one input. This will go to input here, and this is the siren. Let's excuse this for a little. This will go here. All right. Now, right now it's not secure. I open the gate. So what happens? The AND gate has one input, but the output is not turning on because in AND gate we need two inputs to be on. So what we can do here is close the door again. Now let's secure the gate, secure the home 1, 2, 3, 4. Now this is armed and we have an AND gate. So if I open this now, you'll have an alarm like this. It means there is some intruder alert. Somebody is coming without your acknowledgement. So you have an alarm. So this can be turned off when you turn off the gate, but this does not generally happen because if you're intruder, close the gate, alarm should not be on, it should remain on. All right, in that case what you're going to do is just latch the siren. Okay, you can latch the siren by another SR bit over here, this one. Take an output, latch the siren, take it as set. Now to unlatch the alarm, you may have one more very good option, this remote control. This is a remote control which is in our home IO having 8 buttons. So I'll turn it to blue so that I can have its control here. So using the button 1, this is remote control button 1. Using this button 1, I can reset this one like this. Okay, so let's see now what happens. It's already secured. I'll open the gate. Alarm is on. I'll close the gate. Nothing has happened. Alarm is remain on. So the intruder is still alert. Now this will only be turned off if I reset this block by pressing 1. This is in my hand, in my control. I can reset the alarm. And instead of going to here and turning on, pressing 1, 2, 3, 4 to arm this device, I can do that by pressing button 2. How? See, here, take the button 2 and use this bit now. Arm. Okay, now without going there, I can do arm and disarm. Okay, let's take one more button to disarm. I'm taking button 3. Oops. Hold on. This is button 3. This is used to, let me show you, disarm. Okay. Now over here it's perfect. Now button 1 is to reset the alarm. Button 2, this is the button 2, is to arm. So this has been logged. Now it has been armed. Without going there and pressing 1, 2, 3, 4, I can arm from here. If I want to disarm, I can press 3. See, by pressing 3, this is off. Now if somebody open the door, it's safe. Close the door, it's okay. If I press 2, now this has been armed. And if I open the door now, you have the door alert on. Okay. Now if I close the door, and I can turn off the alarm by 3. 3 is to disarm this, turn off the alarm by 1. So that's the integration of various controls in just siren operation. All right, this was the example of siren alert. Let's see what we have more. I'm just closing this from here, and I don't need this bit. All right, let me extend that. Okay, now you also have a lot of switches here. This is on and off switch to turn on the lights like these, and an off switch to turn off the light. So let's see how we can do that. Very simple. Just take this control of connect IO. In connect IO, you can use this control. Okay, let's try this roller blades instead. I want to use this switch to turn up the rollers and turn down the rollers. So I'm taking its control, rollers control. Okay, let me find out its control. It's over here. That's the control. Okay, now these roller will be operated by the switch here. It's very simple. I just activated the control in connect IO. Here you will find roller shades up and roller shade down. This is down, this is up, this is switch up direction and down direction. Very simple. So if you press up, this will go in up direction. If you press down, this will go in down direction. Pretty easy. So let me see that. Now if I press it like this, this will open. If I release it, it will pause. It will open again. Sorry. Alright, if I close it down, it will close down. Okay, this is how I can automate, not automate, but I can control my roller shades based on my switches. This thing I can also do by my brightness sensor. If it's day in the morning, if it's luminance during the day, I can open the roller blades. During the night, I can close that automatically using this bit. I hope you know that. This time, now let's see what we have more. We also have room control system. We have heaters here, and we have PIDs here, some temperature control. Using that, we can control the room temperature as well. All right. Now we also have a smoke sensor. This is a smoke sensor to alert when there is a smoke in the home. Using that, we can also activate our alarm, which is over here, and also we have an alarm outside the home. Okay, so we are actually in the entrance area, and we also have a lot of personal rooms here. Now let's see. This is one of the room in which you have all the same controls. You have motion detectors, we have brightness sensors, room controllers, and then if you close the door, we have a switch to turn on the light. We have lights in the top. This is a smoke sensor, and these are the roller shades which you can turn on and off from here. These are the bed switches. All right, so right now I'm in the section J. I'm showing you how you can quickly move around. You can go to section K. This is the section K. This is a washroom, looks like a washroom. Then you have a section H. This is another room with another controls. You can customize your control based on the logic. Then you have section B. This looks like a dressing room. This is again washroom. Then G is a corridor, and then M is another. This is a kitchen where you can also control the temperature and the light. And we have a section F. This is a garage. All right. In garage, you have a lot of controls, like you have motion detectors, brightness sensor, and then provision to open the garage. This is by switch. You can also do it by sensor, which is outside the building, and you have all the controls over here. All right. And another amazing thing is, I'm just about to close. Another amazing thing is you can control the temperature of the home IO from here. This is minimum, maximum temperature. You can control the humidity. You can control the wind speed, and you can control the cloudiness. You know why we do that? Because if you're going to automate a home for the whole season, you may have variation in your temperature, you may have variation in your wind speed during the year, and that will affect the behavior of your room controllers, which are already inside, which are controlled by of your controllers, and you can see your energy consumption here, your day consumption, last day, last week, and last month. So you can calculate your consumption in home IO of how much energy being consumed by your automation. If you're automating really well, you can save a lot of energy. If your automation logics are bad, it means it's not working properly, then you may lose energy, because home automation is all about automating the home, reducing the efforts and controlling the energy. All right. One more thing feature is this time feature you already know. And you can have your personal latitude and longitude feature in this map. You can move around anywhere. Then you have a touchscreen inside to create scenarios. Now what happens if I take this red instead of red, if I make it to green, I will get access in the screen. This is touchscreen. So I have a motorized device, which is O. Heating device I don't have. Intrusion security, this is entrance gate. And using scenarios, you can create your scenarios, how you want to control the gate using this touchscreen. All right. By moving it to red, it will not work. So this was a little brief about home IO. And if you want to explore more, I'll give you an offer in the end, how you can learn this home IO, how you can utilize this for yourself, for your kids, for your friends, or if you want to introduce that in your school or universities, you can contact definitely. And this is the Connect IO, by which we can control the home IO environment. Now you might be wondering why to learn Connect IO if there are so many other controllers available. So the flexibility of this Connect IO is you can connect your DAQ card. If you have a DAQ card, it's a data acquisition card, you can synchronize your DAQ card with your own controllers. We have done various experiments. We have controlled this home IO using Allen Bradley PLC, using Delta PLC, using Siemens PLC. So by making logics in your PLC, by using timers, counter, rising edge, falling edge, there are so many other latching, unlatching, set, reset. You can control the home IO by this Connect IO integration of DAQ card. This is an amazing feature. And if you want to work on analog, we have 4704 DAQ card, which can be linked with your analog devices. If you want to explore more about this analog and digital interfacing, we'll be publishing links in the event page where you can see how to control home IO using external devices, using hardware switches, which is the switches which we have in our home or in the push buttons. You can control the lights of home IO using those switches by this integration. All right, this event is moving very fast. Anyway, so this was about brief highlights about home IO. Now in home IO, we have a course. If you want to explore more, this is a course in which you'll find almost 37 lectures with 4 hours of content. With these contents like understanding the environment, types of sensors and actuators in detail, open the gate using infrared sensor, latching the gate, then time conditional opening of gate. This is exercise for practice. Then automation of garden and pool light, analog operations, exercise for practice, then automation of garage, then entrance door, the roller shades. And here we also have energy saving, how to save the energy. And the best thing is we are working on real-time control system as well. So in real time, you can control, this is a real-time based, that you want this home IO at night should, for example, we have a sensor near the gate. All right, because real time is really a good feature in home IO. This sensor, during the daytime, it will work as a signal to turn on the light. Okay, but during the night, the same motion detector will work as a siren alert. How that is possible? A single sensor having two functions during the day and during the night. This you will see in the course, and how we can have a real-time control using this real-time opening of gate as well and real-time sensor alert as well. You can understand. So we have a lot of lectures here. These are the video lectures. You can understand. All right. Along with that, you'll find some interface of DAQ cards, controlling home IO by external switches, controlling home IO by external potentiometer, controlling home IO by PLC Allen Bradley. You'll find some integration here, and these are some activities. And if you buy this course, this will cost you $99 plus this home IO software, a licensed software for 90 days. This is a student version edition. So the cost of course is $49. Cost of the software is $50. Together you're getting it for $99. And I'm giving you one more offer. If you buy in another 15 days, we will give you Learn 4 PLC in a Day, a course worth $99, totally free. In this course, we have more than one 133 lectures, 16 hours of content on PLCs like Allen Bradley, Siemens, Delta, and Schneider. 100 plus PLC videos, and along with that, you have these many lectures, all the highly complex, sophisticated commands. And this is one of the best course of PLC in the Udemy market. This you will get as a free. So for more information, write to me at rajveer_43@gmail.com, or you can post the comments in your live video event. All right. Thanks for watching. For any queries, just give me a feedback. Thank you so much. Enjoy.